Hey, so this is my second screencast talking about Catena and going through the code a little bit, and this time you can hear me and see me. So that should be a little interesting. Um, so this time I want to go through extents, um, which make up disk partitions. So an extent is essentially a compressed array of points. And the reason why partitions are made up of extents is because it makes seeking into the middle of a partition much more efficient. So if you have a compressed stream, you can't just seek to the middle of the stream because that requires you to decompress from the beginning. Um, so if you wanted to read the last few points in a partition, um, if you didn't have extents, you would have to basically decompress the entire partition's worth of points for that metric. So extents make that much more efficient. So they're actually not too difficult to implement. So an extent is defined with three things. The starting timestamp. So if you want to get a point, you can figure out which extent it probably belongs to using the start timestamp for that extent. And then we also have an offset, which represents the offset in the file, and the number of points, which just there to help us know how many points to decompress. So if we go back to the partition definition for a disk partition, which is represented as a single file on disk, the struct actually doesn't contain any points. So the only thing that the partition contains is the metadata that describes where points are. So in this case, we just have a map from the source name to the metadata for a source, and each source has a bunch of metrics, and for each metric, we just store the extents that are present for that metric. So if you can imagine the way we read points for a single metric, if you ask for, let's say, timestamp 10, we first look at all the extents and then see which extent probably has that timestamp, and then read that off the disk. So we don't store any points directly in the partition handle, basically. It just serves as a record of the metadata, and then we basically read those points on demand. So that's pretty neat. So to actually read off an extent, it's pretty simple because we have that metadata and the offset. We just basically open up, make a new IO reader that reads into the memory map file, which is just a byte slice. So that's pretty convenient. And we can seek to the offsets. Which is defined in the extent. So after we do that, we just make a gzip reader, read off the points. It's really simple. And yeah, so that's basically how points get read off an extent. So let's look at how points get written into extents. So remember, all points start off in a memory partition, and when it gets time to compact a memory partition, a new file gets created for the disk partition, and then we basically just iterate through all the sources and all the metrics and all the points, and then just compress them and write those directly to disk. So here's how that works. The first thing that happens is we have to figure out all the sources and all the metrics. Um, so the raw partition data gets written first, and what I mean by that is um, all the sources and all the metrics and all the points get written directly um, onto the file. So that way we know when each one of those extents begins. Um, so basically, the offsets get stored into the metadata at the end. Um, and basically, the way that works is um, in the beginning of a disk partition, there's no metadata at all. There's just extents, and the extents have points, and it's very, if you were to just look at the raw data, it would be meaningless because there's no association between sources and metrics, and you wouldn't know where anything is. So all that metadata gets stored at the end. So if you think about how a disk partition gets loaded up or opened, the first thing that happens is we seek to the last 4 bytes or 8 bytes. So you look at the last 8 bytes, and that tells you the offset where the metadata starts. So you go all the way to the end, figure out where the metadata starts, go back to the start of the metadata, and basically read all the metadata. And that tells you where, in the beginning of the disk partition, all the points in extents are. So, in order to build up that metadata, the first thing that you have to do is go through each source and each metric. And then for each metric, you have to take your slice of points, split it up into extents, which is pretty straightforward. You just make a slice of extents, and for each point, you basically append points to the current extent until it reaches a certain size. Right now, it's fixed to 3,600 points. Once you get to that size, you move on to the next extent, and so on. So pretty straightforward. And after you write all the metadata for that extent, you basically, before you write everything down, you remember the offset. So let's see where that is. There it is. Yeah, so to get the current offset, we have to do something, kind of silly. We actually have to seek, but we don't seek anywhere. We seek with an offset of 0. So what that basically does is it doesn't move your cursor in that file handle or the right seeker. It just returns the current offset. There's actually no function to give you the current offset. I think, I don't think Linux has that. And so it just sort of like bubbled up into other things. So seeking nowhere sort of gives you the current offset. So it's kind of interesting. 1 basically represents the current offset. So you seek relative to the current offset. So we don't seek anywhere, and you get the current offset back. So kind of weird, but whatever. That's just how it's done. So before let's see. Yeah, so the current offset here tells you where the metric data starts. And then for each extent, you record where the extent offset is. You write the data for that extent, and then basically keep track of all that metadata. And at the end, once all of the extents are written, you actually go through and write down all of the metadata, which includes all of the sources, all of the metrics for each source, all of the extents for each metric, and their associated timestamps and all that stuff. So basically, whenever you need to read a point, um, there's no disk seeks involved to figure out where that point is, because all that metadata is stored in memory. So we go back to the disk partition. If you want to read a point, you just figure out which extent it belongs to, and then you have to read out the entire extent. So there's a few interesting optimizations that can be made. So once you decompress an extent, it gets stored, that partition slice gets stored with whoever decompressed it. And in this case, with disk extents, the iterators are the ones that hold on to those things. So if you can imagine two iterators that are accessing the same points, we decompress that extent twice. So that's not too efficient. If you have an extent that's really, really popular, if it gets accessed really frequently, we'll end up decompressing that extent multiple times, and there's no extent cache, so to speak. So that's one place that this can be optimized, but it's a lot more complicated to do. It's not simple. Yeah, besides that, there's a lot of other stuff that happens with iterators. But since this video is long enough, we'll just save that for another time.